Welcome to another video. In this video, we're going to talk about arrays. Arrays, you can just think of them as like a list of items. So it could be like a list of numbers like 1, 2, 3, 4, or it could be like a list of names, for example, and Billy, Joe, Sally, Jane. So we're going to talk about the purpose of arrays. We're going to explain how to declare a one-dimensional array, which is you can think of it as a list. We'll describe how to implement a pretest loop using the for each next statement. We'll also look at how to calculate the average of values in an array, how to find the highest value in an array, and then we'll describe ways of sorting a one-dimensional array. One thing we will not be talking about in this video is two-dimensional arrays, which that's more like a matrix or a table to where you have columns and rows of data. That is something that I'm not going to talk about in this lecture. I do encourage you to at least be aware of them, what they are. And, if you feel like going ahead and reading that portion of the book, of the text, feel free to do so. But I'm not going to cover that. I'm going to consider that an advanced topic, something that we will not discuss in this course. Arrays. So far we've talked about a single variable that contains a single value. An array allows us to be able to have more than one value, or more than one value in an array. So it's like I was saying, it's more like a list. You can have as many items as you want in the array. You just have to specify whenever you declare or initialize the array what value, how big the array should be. Up to this point, if we needed several variables, let's say, test scores for a number of students, you'd have like score 1, score 2, score 3, score 4. Those would be the variable names. Arrays allow you to be able to have a single variable called like scores, and then be able to access the first element, be able to do some math or calculations, whatever we want on it. Access the second element, third element, and so on. So let's talk about declaring one-dimensional arrays. So the way that we access one-dimensional arrays is we start off with a 0 for a subset, as you can see here. So here's our one-dimensional array, int sales, and we specify the first element as being an open parenthesis, a 0, and then a closed parenthesis. Here's the value. The second element in the list, we specify the name of the array, which is int sales, open parenthesis, value of 1, close parenthesis. Now you could do the same thing by saying like int sales 1, int sales 2, int sales 3 to be different variables, but that's not very efficient. So that if you're thinking, as single variables, that's the way you would kind of do it. But if you've got a number of values, you definitely want to use an array. Notice that each one of these is a single memory location here. So let's look at some syntax of declaring a one-dimensional array. We start off with the keyword dim, the name of the array, and then in parentheses, we put how many elements are in the array. So this actually declares a 3-element procedure level array called string warehouse, where each element is automatically initialized using the keyword nothing, because we don't set it equal to anything out here. So if you don't set it equal to anything, there's nothing in the string. So you specify it this way, and then you say as, and then the data type, which in this case is string. In example 2, we're going to have we're going to say that it's static. In other words, once we put values in there. So here in example 2, we have static int totals 4 as integer. This will contain up to 5 elements. It's one more than what we have here. And we name the name of the array is int totals, and it will hold integers. And since we don't set it equal to some initial values, they're all set to the value of 0. In example 3 down here, we have string names as strings, and we don't specify the number of elements because whenever we set it equal to this list of items here, the compiler can count these and know how big the string names needs to be. So you don't need to specify a value here. It does that automatically. And then example 4 here, we have another array called int sales. We're not specifying the size because we have the values off here to the side here, 1, 2, 3, 4. So it'll hold up to 4 values. Now you can have dim, private, or static. Private means that that's going to limit where you can access the array. In most cases, I say use dim because that allows the most flexibility. That way you can access, put stuff in there if you need to. You can change the values. But if you do know that you're going to have an array with static, with values that are not going to change, you would use static. And private allows you to only be able to access that in the current scope. So moving along, let's talk about how to sort data in a one-dimensional array, or storing data in a one-dimensional array, sorry. Let's say that we have, as in example 1 down here, we have an array that'll hold up to 6 elements. It's going to be a string. And we can set the first element in the string equal to Nashville by writing string city, open parentheses 0, and close parentheses. In example 2, we're going to declare an array of numbers that are integers, and then we're going to use a for loop that counts from 1 to 5, and it's going to take, it's going to set in that, in like the first location, a number, which in this case can be 1, and it's going to square it. So it's going to take each element and it's going to square the values. So it's going to have 1, 2, or 1, 4, 9, 16, and 25 put in into the array. Example 3, we have an array of numbers, 5 elements long, numbers of type integer. And here we're going to use a do while loop that is going to initialize each of the values to 100. Now you could also do that by initializing the setting it equal to, and then 100 comma, 100, 100, 100. But this is another way to do it to show you how to use a loop. In example 4 here, we have some prices and 3 prices, and we're going to take the value in the second location, and we're going to multiply that by 1.25. And in example 5, we have 10 rates, and we're going to take some value from a text field called rate that's being user inputted. We're not sure what the value is, but we're going to, well, we're going to take whatever's in double rates in the third location and put that into the text rate field. I misread that, but yes, that's what it's going to do. How do we determine the number of elements in a one-dimensional array? There is a length property that helps us to do that. So if we have an array to find out how many elements are in it, you could say the name of the array dot length, and that will return an integer value, which in this case up here, the size of string names is 3. And so the length is going to be 4, because remember, we got whatever our length, whatever we initialize this as, remember it starts at 0 and it'll go up to 3. So we have 0, 1, 2, 3, and that's 4 elements. Determining the highest subscript in a one-dimensional array. In a one-dimensional array, the value here in between the parentheses will always be a 0. And so what this is going to do is it will return it returns the largest, it'll return the largest or the highest subscript, which in this situation is 3. Something to note here is that the get upper bound is usually 1 less than the length. Now we've talked about how to put values into an array. Let's talk about how we can get data out. Let's say, for example, we want to traverse. In other words, we want to access each element in the array. And so let's say that we have a list of names and we want to add those to a list in a list box. And so we could do that with using something similar to what we have here, to where we get the upper bound, we put that in the high subscript variable. We then count from 0 to the high script value. And this list names, which is a list box, it'll add in the each element starting from 0 up to whatever the int high sub is. And it'll continue adding those elements. You could also do something similar with a do loop. I recommend using the for next, because I think that is one thing. It's a little bit shorter. You notice it's 1, 2, 3, 4 lines instead of 1, 2, 3, 4, 5, 6 lines. And so the for next loop seems to be a little more efficient. But you could run it with a do loop if you absolutely had to. And there are circumstances to where you may want to do something with the do loop instead. So we list it here. And so here we've got the int high sub like what we had before, except that we're taking the length and we're saying length minus 1. So we get the high sub. And then we have a counter variable called int sub that we will use to keep track of where we are in our array. And we'll check that while our int sub is less than or equal to the high sub, we will then add each element into the list, and then we have to increment the int sub by 1 each time. Notice here that you've got to do a little extra work. One thing is you got to do that comparison to see if the int sub is greater than or is still less than or equal to the high sub. Then you got to add 1. So it's a little extra work. Like I said, the first one here with the for next is definitely more efficient, and that's what you should use in most cases. The for each next statement, we've talked about that, but we'll spend a little bit more time talking about it. So notice here that you would have a variable a new variable, which in this case is a string element. And you specify it as a string because our string names is also an array of strings. So these data types have to be the same for string element and string names. Notice here that we're adding that in our list names list box. We can calculate, let's say we have a list of numbers. We can calculate what our average pay is. What we would do is go through each element of the list, add it to a total, and then we would then divide by the number of elements in the list. Notice that there's a couple different ways of doing that. The most efficient way, I believe, is example 3, where it's for each next statement. Notice here there's only 3 statements here, 3 lines of code versus the others that are larger. I would definitely, if I was writing the code, I would do it as it's done in example 3. The other 2 I consider to be less than desirable. I would not write the code that way. There are probably certain circumstances to where you may have to do it that way, but it's best to try to write it as it's written in example 3, if at all possible. And so what we're doing here is for each value that's in our double prices list or array, we're taking each element, and that's being put in a variable called double day, and then it's being added to the total. So notice here that by doing that, you don't have to worry about subscripts, you don't have to worry about any of that kind of stuff. You're going through each element in the list, and you're just adding, taking the value and adding it to double total. Notice that in example 1 and example 2, you've got to worry about subscripts, you got to worry about all that kind of stuff. You got to worry about adding, incrementing your subscript value like you do here in the int sub. You don't have to do that in example 3. It's just taken care of for you. There's less code here, less chance of you creating a mistake. So it's best to stick with example 3. Finding the highest array value. Very similar to what we've done before. Let me see if the code's actually here. Really, the only thing that we have to do is we have our for loop here, and we just check to see if our value is the highest value. And if, I mean, it's higher than the values we've seen so far. And if it is, then we would add, or we would set our highest variable, or variable called highest, set equal to that value. And if not, we just go on, and we just keep doing that through the whole list here. And I think there's probably even more efficient ways of writing it than what's here, or what I would consider more efficient than what's shown here. I think you could write it even shorter than this by a couple of lines. Notice that in both of these if statements, you have int days. Well, wait a minute. Nope, I misread this. It says int days equal to 1. This says int days plus equal to 1. So no, it wouldn't be more efficient. And actually what this is doing is it's checking to see the number of days that has the highest value. So I misinterpreted that. It says display the highest stock days and the number of days that has that highest value. I thought we were just calculating the highest array value, which is what's shown here in pseudocode. Sorting a one-dimensional array. Sorting is very important in computer science. Whenever a lot of times you're trying to find a certain value, And the easiest way to do that is to have a sorted list. If the list isn't sorted, you got to go through each element of the list until you find your element. You don't know where it's at. It could be at the beginning, it could be at the end, who knows? If you've got a sorted list, there's a better chance of trying to figure it out. If you're looking for a certain value, you can do a divide and conquer technique, which is if everything is sorted and you're trying to look for a certain value, you can start right in the middle of the list and see if the value in the middle is greater than or equal to the value you're looking for. And right away, you can eliminate half the list, because if the value you're looking for is less than what that middle item is, then you know that the item you're looking for is in the left part of the list, not in the right part of the list, and you can eliminate half of the list automatically. So sorting is very important. Sorting allows us to be able to quickly find information. And if you continue with your education in computer science, you'll find out that we spend a lot of time talking about sorting. You'll actually spend several class or two if you decide to go for like a bachelor's degree or something one of these days. It will, if you're going to like transfer to another school, there's a possibility you could take a class or two that's all pretty much all they talk about is sorting, and how long it takes to use different methods to sort. But we won't worry about that here. But Visual Basic provides a sort routine or function, whatever you want to call it, that does sorting for us for the elements that are in our array. So the way that that's called is you call the name of, you use the word array.sort, and then you put your array in between parentheses, as we have here, like for the int scores, and it will sort those elements. So if we have int scores, and let's as an array, and it has elements 78, 90, 75, and 83, by calling array.sort with the int scores as an argument to sort, it will sort it so it's 75, 78, 83, and 90. In example 2, here's another list of integers. There's also a reverse method in Visual Basic that will take the elements and will put them in the reverse order. Not in reverse sorted order, but in just the reverse order of what the current order. So in example 2, you have 78, 90, 75, and 83. Whenever you put it through the reverse method, it comes up with 83, 75, 90, and 78, which is the reverse of our initial array here. Now, if you want to have a reverse sort, in other words, them in reverse order, you've got to sort them first in increasing order, ascending order, and then you can call array.reverse, and that will reverse the items so that you've got them in descending order. As you can see here, 90, 83, 78, and 75. Two-dimensional arrays, as I said, we're going to leave that as an extra activity if you want to look at them. They are very important. Something that you probably should look at eventually. Right now, I think it's best for you just to know that they exist and that you may need to use them sometime in the future. They are kind of handy, but we need to first worry about you mastering one-dimensional arrays. So I will leave that for another day. Thank you for watching this video.